In this question, we need to drag each equation into its corresponding category as being either quadratic, linear, or exponential. Let's first start by graphing each of these equations to see what the function looks like. Let's start with the equation y is equal to 2x. If we start by substituting in -3, our output value is -6. If we substitute in -2, we have -4, and so on. Notice that we have a straight line. Therefore, y equals 2x must be a linear function. Next, let's look at the equation y is equal to 2 brackets x minus 1 all squared. Let's start by substituting in -3. When we substitute in -3, the corresponding output value is 32, then 18, 8, 2, 0, 2, and finally 8. Notice that the shape that this graph makes is clearly a parabolic shape, making it quadratic, and so therefore this function we can put in the quadratic category. Next, let's try the function y is equal to 2x squared. Beginning by substituting in -3, -3 squared is 9, 9 times 2 gives us 18, and following in the same fashion, we have 8, 2, 0, 2, 8, and finally 18. Notice again, just like the last one, this makes a parabolic shape, therefore y equals 2x squared is quadratic. And then finally, we have the equation y is equal to 2 all raised to the power of x. In order to complete the table of values for this question, it's a little bit more complicated. You may need a calculator to assist. If we substitute in -3, we get the corresponding output value of 0.125. -2 gives us 0.25, and so on. As we can see, this function does not look to be linear. It's clearly not a straight line. There's aspects of it that may look to be quadratic on this part, but you can see that these values are flattening out, so therefore it can't be quadratic. So by process of elimination, because you're not familiar necessarily with an exponential function, we can put this one in this category. Finally, there's a way that we could have avoided graphing these. You may have noticed a pattern. Linear functions are first-degree functions. The x variable is technically raised to the power of 1. Notice that our quadratics are raised to the power of 2, and our exponential ones are clearly different than the others. This one is raised to the power of x. Let's check our solution, and we are correct.